All right, good morning, good afternoon, good evening, everybody. Thanks again for joining on this episode of CDK Office Hours. We're going to be talking about custom resources part 2. In the previous episode, we talked about part 1, and I tried to build a custom resource showing you how to do that with the CDK, and it failed. So the first thing we're going to do today is we're going to talk about that failure and why it failed. So first thing is, if you'd like to follow along, I pasted in the chat a link to the custom resources repo where all of this code is at. You can always grab that, follow along. There aren't a whole lot of commits in there right now. The primary one, or the few that are in there, are all tagged with kind of steps as we go through here, so you can go back and review it. Hey, Alex, thanks for joining today. Nice to see you as always. All right, so let's get started. The first thing we're going to do is we're going to go back over here and we're going to look at what we had before. This was a handler for our Lambda function that backs that custom resource, and it fails. Now, we go out here and I'm going to go ahead and do a deployment on here so you can see what's going on. Now, I always like to do a diff first. In this case, this should be a brand new stack going out. So I should see here basically just a big long, new stuff, new stuff, new stuff sort of thing. And going back and scrolling through here, yep, that all looks fine. So we'll go ahead and do a deploy. Now, as this goes out, it's going to create the DynamoDB table. It's going to create a Lambda function. It's going to create a custom resource. That custom resource is then going to execute that Lambda function, and then it's going to fail. Particularly, it's just not going to do anything. The response back to CloudFormation to say that the custom resource was completed, this line 12 right here, that's not going to execute properly, and the stack is going to hang. Now, the reason why I'm showing this to you is because I want to show you why I always put this line at the top of pretty much all of my handlers. It's going to give me an option to fix this problem and try to not have to wait an hour for this entire stack to fail and roll back and all of that good stuff. So we're going to hop over here into AWS and we'll take a look, and we can see our stack is being created. And if we just give this another moment here, we'll start to see things like we got all of our creates in process and all of that various good stuff here. We'll just give that a minute. Now, if I had been paying attention and if I've been looking closely at this code, I've actually got WebStorm telling me right here that there's a problem with this command. And if I look, the issue actually here is that this is an asynchronous call. I need to make an await on it. WebStorm actually picked that up just fine. I did not. And you can see here, as soon as I put an await in front of it, my send goes back to being good, and everything would potentially work right. But for now, let's go ahead and pretend like I didn't see that, and let's see what happens over here in CloudFormation. So we've got some resources creating. We've got my IAM role is all done for the Lambda. My DynamoDB table is done. It's creating the policy now for that Lambda function. So this will just take another moment. We got our Lambda function loaded, so that's good. Let's actually go over here into our logs, and we should be able to start to see a log group show up here in just a moment. Good. So we get our log group here. And if we take a look here, the custom resource has already been called. We get some information in here. We can see that it's running and the function is done calling, but the custom resource over here on this side, it hasn't registered as complete yet. I can hit the refresh button here and see it's never going to. So if I didn't do anything else at this point, this stack is going to take about an hour before it times out. And then it's going to try to do a rollback of this stack. If you've been paying attention in the last couple of days, CloudFormation as well as the CDK has released a feature that would say that, hey, don't do a rollback in that case, but I haven't enabled it at this point or anything. But we'd go through, we'd hit this, we would see that the custom resource is not going to ever complete. So I don't want to wait an hour for this. And I also don't want to sit here and start doing weird things like, well, I could go ahead and try this again by changing my stack name. But instead, what I'm going to do is I'm going to come in here, and this output right here in my console.log shows me the entire event that I care about. So I'm going to go over here and I'm going to copy this to my clipboard, and then I'm going to go find my Lambda function. And once I have that, I'm going to go over here into my Lambda function. I now know exactly what the problem was. It's not obvious from these CloudWatch logs what's going on, But I know from working with custom resources for a while, I know with working with asynchronous JavaScript for a while, that even though this response looks like it went through, it's obviously not happening quite right. So I'm going to come over here and I'm going to do two things. First thing I'm going to do is I'm going to edit my code. And thankfully, I've got the nice little Cloud9 editor built in right here. I'll go ahead and scroll all the way down to the bottom where I've got my code right here. And I'm going to add my await. Now, this would be kind of pointless right now because the function's already been called. It's not going to naturally be really called again anytime soon, or at least I don't want to wait for that. So I'm going to go up here to this test. And I'm going to go ahead and create a new event. And I'm going to say whatever. Don't really care what my event name is. And I'm just going to paste this in here. Now, this is why I always do an output of the incoming event on my handlers and why I always output it to a nicely formatted JSON, because coming in here and copying and pasting this is something that I end up doing a little bit more than I probably want to admit. So I go ahead and I create this. I go ahead and I run my test. Now, at this point, the function's going to run. It's going to complete like we did before. I actually get this time around a status code and a message, which I wasn't getting before because, again, my asynchronous call was not really completing properly. Now, if I go back over here and I look at my CloudFormation stack and I do a little refresh, what I'm going to see is now the stack has actually completed successfully. I forced the system to sort of simulate another custom resource call to my Lambda function. That's my test that I put in there. And then I go ahead and now the code works correctly and my stack is all done being processed. And that's fantastic. Now I don't have to wait like 2 hours for this thing to turn around. So let's go ahead and fix this up properly. I'm going to go ahead and instead of typing code this time around this week, I'm just going to go ahead and do some good old magic with Git. So now we've got this await in here. Everything generally should work fine going forward. So let's actually move forward and do what this fixture was meant to do, which was take the incoming data. Going back here, when I create this fixture, I go ahead and I pass it some records that I wanted to put into my DynamoDB table for me, and that's what my fixture does. So I'm going to go ahead and start to fill out that code. Now, this is very specific around interfacing with DynamoDB. I don't see there's a whole lot of value of going through and showing you the writing of the code. We'll review it here pretty quickly, just so you guys can see exactly what it is that's going on here. But in general, if you don't understand what this code is doing, if you don't care to understand, that's totally fine too. But at the beginning, what I'm going to do is go ahead and import in here some of the DynamoDB client libraries. These are the version 3 libraries for Node SDK, so everything is very object-oriented. In fact, it's now working very similar to how the CDK works. So if you've been very familiar with the CDK, but you've been working with the V2 version of the Node SDK and everything, well, this should start to feel a little bit more familiar to you and everything. Any chance that this will be recorded and made available on YouTube? Yes. So I am recording this right now. When it's all done, I'll go through, do a little bit of editing of it, and I'll put it on my YouTube page. And I think that's just YouTube/MattBonig, or I'll post some links here at the end and everything for you. So, all right. So now I've filled out this Lambda handler code. First thing that I'm doing is, again, some basic outputting of some values. This comes in really handy when I'm doing the development, just to make sure I'm dealing with what I think I'm dealing with. The next step is I went ahead and added in something that we didn't have before, which is if this is a delete operation, if we are trying to delete the custom resource because either we've removed it from the template or we're deleting the stack as a whole, then in the case of fixture, there's nothing to do. I'm not going to worry about trying to delete the records from the database. I could, but I'm not going to worry about that. Instead, I'm just going to go ahead and register a success on this delete function and move on. Next up in here is really just the DynamoDB client. So I'm going to go ahead and create a new instance of it. In this case, I'm using the DynamoDB document client. It's a little bit easier to work with, although even then there's some funky issues with the V3 that we need to figure out, but that's fun. And then I go through all of the records that were passed in on the custom resource. Again, these records right here, they were done in the CDK constructed definition. Those have now been part of this record that's passed into us during the event. And I'm just going to go through and for every one of those records in the system, I'm going to go ahead and use the client to put this item in the DynamoDB table. And if I get through all of the records and everything works just fine, then I go ahead and I send my response back to CloudFormation saying everything worked. If for some reason there was a problem with that, then I'm going to go ahead and log to my console what the error message was. This is always good to have just in case in your CloudWatch logs. And then I'm going to go ahead and register that there was a failure on this custom resource, and that will make the stack roll back, and all those changes will be reverted back. Let's see here. Yep, yeah, if you fail to get that delete, you can definitely run into some problems. So you always kind of have to watch this. So let's go through and let's go ahead and try this again. We're going to do another deployment of this. Now, real quick, let's go back and take a look at the fixture itself, because there was one change that I had to make here. Originally, my document that I was handing over was just a basic plain JSON object. It had the primary key, it had a value on there, but I wasn't doing this sort of DynamoDB notation where you have to say, well, this is going to be a string value and this is going to be a string value. You could also do number values or Boolean values. This is a little bit of the DynamoDB notation for objects. There are ways that you can convert this from or get an object like this from a basic JSON object, but I was under a little bit of a time crunch and I didn't find a great solution. So the easier one here is I just went ahead and made it more DynamoDB compatible, and that's of course just what gets passed in here through the record. So if we go ahead and we deploy this out, what we should see then is that the stack will get deployed. Let me double check one thing. Did I change my stack name? Nope, that should all be the same. So it's going to go ahead and deploy this out. If everything goes according to plan, then the custom resource will complete successfully because it will have written those records into DynamoDB correctly. One other thing I wanted to mention here that was a change from last week. So if I go and I take a look at this table fixture, the properties on this custom resource, I added this new additional timestamp on here. This wasn't here when we were talking a couple weeks ago in episode 1. This timestamp is really just to enforce a continuous update of this record. So if I didn't put this on here and I hadn't changed any of my records, then the custom resource isn't going to register a change. It's not going to call the Lambda, and I'm not going to get the records on my database. But in the case of a fixture, it's kind of nice to always run it. Maybe not in this case, but for demo where I felt that this was a good thing to put in here. So this timestamp forces the custom resource to always register a change, always call the Lambda, and always get the things that we expect it to get. So let's go ahead and hop back over here. We can see that our changes did go through. Interestingly enough, we actually have a delete, which I'm guessing we can dig into a little bit, but it's neither here nor there. Let's go and take a look at our database table then. So we'll hop over here into our DynamoDB console, and what we should see is our table. We should see the one record that's in it, and ignore all the other tables you may see here. This is kind of a weird sandbox account for me. So anyway, there we go. So we've got our something whatever record in here. Our fixture is now generally working the way that we would want it to, and other than a couple of minor tweaks here and there, this is more or less kind of, I would say, production ready, if you would. This is going to be probably about 90% of the way there for what you want. Oh, hey Brett, nice to see you join us, and welcome. I don't know if you were on last week, but hope you enjoyed so far. So let's go ahead and talk about why you should probably never really do this, though. So I talked a little bit about how I created this custom resource. I have this Lambda, and if I go over here and I look at my fixture here, my fixture handler, there's actually a couple of things that are going on here. I'm going to make this a little bit smaller so we can see all the code at once. So if I look at this code, there's actually two things here that this handler is responsible for doing. One, it's responsible for knowing how to get the data into the database via a DynamoDB call. And two, it has to know how to respond back to CloudFormation to say that that either succeeded or that failed. Now, I'm a big proponent of the solid design principles, SOLID. If you haven't ever heard them before, no problem. A lot of people have not. Go check them out online. Just do a search for solid software design principles. It's an acronym for single responsibility, open close principle, blah, 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 blah. But the one, that S at the very beginning is the important one, the single responsibility. This is probably one of the tenets that is often broken the most in software development, and is probably one of the most valuable to try not to break, at least in my experience and with the code I've written, which is anytime you write a function, anytime you write a block of code, it should have one single responsibility, and that's it. Anything else that would necessarily have to get done, you should defer somewhere else. The logic, not necessarily the execution, but the logic of what needs to be done shouldn't be mixed in together. And in this case, this is violating that single responsibility. It has two responsibilities. It has to write the data, and it has to notify CloudFormation on how to handle this. And as we saw, it's really easy to get that wrong. And if you get it wrong, it can be very painful. If, you know, when we did this a couple weeks ago, getting it wrong meant that the stack would never complete successfully. It would take an hour before it timed out on its own. And then it would take an hour to roll back because the delete would also fail, and the stack would eventually end up in this, you know, rollback failed or delete failed state, and it's not good. And losing 2 hours of your day because you forgot to put in a wait word in there is painful. And yeah, you can do what I did, and I showed you at the beginning, of going and creating a test record based on the thing that was sent in and sort of fake it. But what happens if your code isn't something simple to fix and you can't just edit it in line and retry it? Well, there's actually a resource within AWS, or within the construct library, that is really meant to make this much, much easier to work with. It's in the custom resource module here, and again, we're just looking at the standard CDK documents here. And it's what's called this provider framework. So the provider is meant to take those concerns about dealing with CloudFormation and the custom resource signaling and make it so you don't have to worry about those anymore. Long and short of it, think of it as a wrapper around your Lambda function that you write that takes care of these calls to CloudFormation to say that something either succeeded or that it did not. As always, go to the overview page on the custom resources where you're going to start to see a good demo of it and things like that. Let's take a look real quick and see what would that look like if I retrofitted this code that we've already seen to work with this provider. And it's actually really, really simple. And that's why I say you probably never want to do a custom resource like we've done here. This provider framework is fantastic. It definitely makes things a whole lot easier to work with. So we're going to start, and we're going to take a look first at what changed in the CDK code. And ultimately, not much. So before, this service token right here on the custom resource pointed to my Lambda function ARN. Now it points to this provider.service token. And now my provider points to my original handler. So, you know, we had a handler, we had our custom resource. Now I'm just sticking this thing in the middle between the two of them. Nothing fancy there. Everything else pretty much stays the same. However, in my handler, I came back over here, and now all I had to do, if you look real closely, is rather than making that call to CloudFormation to say send this success message or send this failure message, instead all I'm doing is returning out of my Lambda function an object, that exact same object I was dealing with before. All I did was remove the send code around it. Let's look at that again and actually see. Let me see if I can actually just show you a diff here. This may be the easiest way to do it. Oh, let's see. I hadn't planned this, so we're going to see if I can show you this diff without too much of a problem. All right. We'll do it this way, and hopefully I can make this big enough. Let's see. All right. Now that'll work. So here on these guys, I had this original line in here that just said, call my send function with this object and a success message. Now I'm just returning back that object. Additionally, on the success we're writing to Dynamo, again, I return back the object. But if there's a failure, now I just let that failure propagate. I rethrow it in this case and let that provider object really take care of figuring out how to respond back with a failure message and those sorts of things. So very, very simple. And what's nice about this is, one, I actually remove a dependency out of my code. I no longer have a dependency on that CFN response object that I was using before that's making the calls to CloudFormation. Got rid of that altogether. Removing code is always good. And I also simplified out this function, so now instead of having to make an additional call to another system, now it just simply returns back an object. And that's really great, because if I was going to go to the trouble of unit testing this, which you always should, it's a lot easier to unit test the return value of a function than seeing if that function made an additional call to another system. To do that, you have to get into mocking objects and all this other stuff, and it's a giant pain in the butt in a lot of situations, and not a whole lot of fun for anybody. So that's about it for the custom resource stuff. Again, this provider really makes dealing with this a whole lot easier. Now, there's a lot of other stuff you can actually do with this provider. In this case, I was just leveraging this on event handler, but there's also this really cool little thing in here called the isComplete handler. So this is a way that you can start to really do these things a little bit more asynchronous. Right now with this test fixture, when I go and custom resource is created, the Lambda function gets called, that operation to load data into the database is probably going to be very quick. But that's not going to always be the case. Think of when you might have to spin up an RDS instance or a CloudFront distribution, things that are going to take longer than just a few seconds to run. Lambdas have a hard timeout limit of 15 minutes. You don't really want to take 15 minutes up anyway, but what you could do is initiate the creation or initiate some sort of process through that initial on event handler. And then if you've supplied this isComplete handler, this is going to get pulled. It's going to get routinely called by the provider over and over and over again, and that isComplete handler is meant to go out, look to see, is your process done running? If it's not done running, if it's still trying to provision whatever the resource is or whatever, then it comes back with a simple false response. If it's all done and everything is good to go, it comes back with a true, and the provider takes care of, again, all the calls to CloudFormation and everything. It takes care of how to pull this thing on a regular basis, and generally takes care of a lot of that sort of long-running asynchronous stuff out of your hands, and a lot easier. So definitely something you want to look at if you're going to be using custom resources. If you need them within your CDK code, definitely lean towards using a provider versus what I've been showing you up to this point, because it's just too easy to get it wrong otherwise, and this thing makes it really, really simple to do. Now, additionally, there is some another resource in here in this module that is also very, very cool. And again, you can look through these documents to see all the various stuff. Again, this is going into the isComplete call and how that all works. But let's talk too about the AWS custom resource. So the custom resource here is a very special object that is very highly opinionated. It's going to be very, very strict in terms of how you use it, but it is also going to really save you from having to write a lot of code. I'm going to go back over here to the overview, because I think this is a little bit easier place to see and read. I'm not going to go through and walk through the code on this today. It doesn't really probably make sense in terms of our fixture example on how to use it. However, there is some potential to use it with it. So if you're interested, go dig into it yourself. If you got questions or anything, of course, reach out to me either on Twitter or on the cdk.dev Slack channel, and I'll do my best to answer any questions there if you've got some ideas on how to use it. But going back to this, what this AWS custom resource is a thin wrapper around making AWS calls directly. So imagine you're trying to get something done with a custom resource that CloudFormation doesn't allow. For example, the password policy that is set up on your IAM account. This is something that there isn't a CloudFormation resource for. If you want to make it so that your AWS account has a very strong, strict password policy requiring 30 characters, uppercase, lowercase, all that. Well, right now, if you want to set that up, you either go through the UI and manually set it up, or you make an API call to get that set up. This is a way that you could wrap that in a custom resource saying specifically, go make this very specific API call to the AWS resources with these specific values, and this AWS custom resource basically creates that Lambda for you that's going to do all that work. So very handy if what you're trying to do is just sort of patch in a little bit of CloudFormation work that doesn't currently exist from first-party support from AWS. If you just want to make an API call in AWS, it's a very simple, very straightforward API call. This is a great resource to do it with. There's some good demos out there and examples of how to use this thing. It's pretty flexible. I have not personally used it yet. I kind of had it on my list to try to do this DynamoDB fixture with it. Maybe if there's good interest from the community on that, I'll make that another office hours cast to talk about all of that. But for now, that's about it for what I kind of wanted to cover for today. Again, if you want to see any of this code, if you want to try it on your side, in the chat, there is a link over to the repository that has all of this code. You can go through it step by step, see what's in there, run each time by yourself and see how it works out. If you have any questions, let me know. Looking over in chat right now. So let's see here. To get a Cloudflare DNS provisioning, it failed to have the delete and took forever for the timeout. Yeah, and that is probably one of the bigger problems. Is if you sit there and you've got a problem when you're working with a custom resource, if you write that Lambda wrong, it can bite you kind of hard in the butt, and it's not particularly fun thing to work around. Let's see here. Custom resources really aren't too bad. Again, if you use that provider, you can really save yourself a lot of pain with it. And once you start getting used to them, you're going to find all sorts of reasons why you want to. Database fixtures is one that I've used in the past where it was a case of we needed to be able to load data into a database, but we really didn't have any sort of nice automated way of doing that. It was only a couple of simple records for a lookup, so this was a good fit. One thing I want to talk about real quick too. This is not production-worthy code. I would not particularly use this in a really hardened, deployable, assumable construct. The main flaw with this is that we're talking about making a bunch of put calls to the database. And if for some reason one of the records you pass in is invalid, well, all those previous ones sort of went in without a problem. They're not going to get backed out. Dynamo doesn't have any sort of concept of a transactional. Now, there are batch writes that you can do. So you can say, write all 25 of these items at one time, or write all 5 of these items at one time. And that's a little bit better way to handle it. The big problem there, though, is that you are talking about there's a max of 25 on that batch write. So you would still need to have a case of, well, now I got to take all the records that was handed to me. In this case, in this demo, it's 1 record. What if it was 100 records? Well, if it was 100 records, I would need to split that up into 4 blocks of 25, chunk it into 4 blocks of 25, and then do those writes along the way. And I may want it to go so far as to say, well, if any of those fail, let's go ahead and roll back those other changes we had. In the case of a fixture, that's probably not necessary, but these are some of the things that this is just very much demo where I would not necessarily expect this to be a great solution for all 100 use cases and things like that. Additionally, there is this part where when I'm handing in these objects to use, I don't really like this notation with DynamoDB having to say that this is a string type. I'd rather hand in an object that doesn't have these notations on it and just be able to pass it over. But again, this put item call really requires that. So if you are interested in taking a stab at it, I recommend you give that a try. Figure out how you would change this handler code, and of course go back to using just standard objects over here, and see if you can make it work so that this would still work without having that DynamoDB notation on it. It's mostly a change around, using the client. I've mostly used the V2 client, not so much the V3, so I'm still learning some of the tricks and things there. So that's going to be it today. This was a little bit shorter than last time, only about 30 minutes. If there's any questions, hit them up in the chat right now. Otherwise, thank you again for joining me today on the office hours. If you like these things, please let me know either on Twitter or over in the CDK Dev Slack channel. If you've got any ideas for what you'd like me to cover in the future, please reach out to me on any of those guys and let me know. what you'd like me to cover. I'd be glad to build whatever you want. Some of the requests so far was an EKS cluster. I'm definitely going to do that on a future one. It's a big request. EKS and Kubernetes is a very fantastic platform for building your applications. Knowing how to do that within your CDK code, first glance, seems real easy. Let's go ahead and just create a construct. But as you get into it more and more, there's a lot of little finer details that we can cover there. So that'll probably be a whole series of office hours about EKS and things like that. If there's anything else, of course, let me know. And thank you again for joining me today, and we will talk to you next time.